Okay, so we got a charge plus Q spread uniformly along the surface of a non-conducting ring of radius, so sort of an insulating ring of radius R0. So you can say this is the distance from the center to the Q, that would be the radius. A point particle with charge plus Q is placed at the center of the ring, so you can add a little plus in here. The net force exerted on the particle Q is which of the following choices? Okay, so yeah, just looking at this question, I guess D doesn't make a lot of sense, but given that I'm giving you the sign of the charges, but I think I could also just state it that a charge Q and another charge Q here is placed, and it actually doesn't matter the sign of the charges because of the sort of symmetry in the problem. So if you've got a uniform distribution of charge, and I don't want to sort of draw it's located on the ring, but since it won't be able to turn up, I'll just draw like slight pluses below, but what I want to do is sort of indicate that these are really on the ring, but since they won't turn up on the printout, I'll just draw them. And I could draw many more, but I want them uniformly distributed, so I've just drawn the 8 here. Okay, so what we can see is that if like I've stated here in this question, that you've got a plus and a plus, then in a sense each of these pluses would exert a repulsive force, but since it's uniformly distributed charge, let's zoom in on the figure here. Like I think that this small bottom one here would exert an upward force on the plus Q in the middle. This plus here would exert a downward force on the plus Q, and it basically would be since they're equidistant, they would basically cancel. And I could basically, if it's uniformly distributed, I could also always pick a pair of charges that act along the line with the plus Q is in the center of that line. So basically, you could pair up all these forces and it all sum to 0. And if it was two negative charges, maybe I can update the question before I post it again to make D a possible choice. When it says to make D more reasonable, it's still not the right answer. If it was both negatively charged, then again you would have the same sort of reasoning that each of all the negatives on the ring would basically repel the negative in the center. And again, you could pair up the choices, and then if they were oppositely charged, again, instead of exerting attractive or repulsive forces, they're sort of attractive. So if the ring was negatively charged, you could have, since an upward force by this, negative on this plus, but again, you'd have an attractive on the other side, so it still end up being 0, whether it's a plus plus, a negative negative, or a negative and a plus, it doesn't matter. So in all cases where they it doesn't depend on it's not dependent on the sign due to the symmetry of the problem and the uniform distribution of the charge. So it's going to be 0 in all cases.